My name is Mark Valliers from San Antonio, Texas. My partner Kirk James is with me. And I left San Antonio with a thought that I'd come up with a Frank Nobilo look. You know, I had a little beard growing, and my wife told me that I looked 100. So if you want to know what 100 looks like, this is what it looks like. So, but anyway, like a lot of us, I struggled with getting consistent readings on profiling shafts. So my background is I actually worked at a power plant for about 37 years in an engineering department. So I'm real familiar with heavy equipment and machining and just general work around power plants and machine work. And I was actually a machinist for 16 years. So when I first got a digital unit to check for CPM, the clutch on the clamp on it was kind of weak. And then when I ended up buying one of these units, I actually ended up getting mine from Golf Mechanics, like a lot of you guys have, or Golfsmith or whoever distributes those. I found that the clutch wasn't working well enough to give me consistent readings. So, and of course, as a lot of us, we use Jerry's BMT profiling software and 5-inch clamps. So I took my clutch apart and tried to see if I could figure out a way to make the clutch a little stiffer, and wasn't able to do that without a lot of work. So I took it off, and I ended up double nutting it, and the first thing I did was just use a 6-inch crescent wrench to get a torque reading, based on my feel, which, with my background, I have a pretty good feel with what I've done with my hands. So that went on for about a day, and then I went ahead and went to our local Harbor Freight and got me an inch-pound torque wrench. Well, like a lot of us also, I have the calibration rod from the PCS, and my number said 306. And I struggled a little bit to trying to find the number, and so I put the rod in there and torqued it to about 25 inch-pounds. And we need to clarify that for sure to make sure we don't use foot-pound torque wrench. And found that my number was about 22 inch-pounds, and that equaled my number of 306 on my rod. So as I went through that, you can go to the next slide. Oh, you already did. So I went ahead and started practicing that, and it became evident to me that I was getting better profiling numbers. So that's a picture of me loosening one. So go to the next slide. And right after I did that, I always would look at the shaft in the 5-inch clamp, and as I would twang the shaft or during excursion, I'd see that the upper clamp would toggle back and forth, and that was a result of the center screw thread being dead center in that clamp, and then as the hoop of your shaft would collapse, if you look at simple physics, force applied down is the same force applied up, and it would allow that clamp to rock. So I said, okay, I'm gonna get rid of that issue. So I went ahead and drilled and tapped the top of the stationary part of the device and made 2 thumb screws out of a 1/4-inch all thread. And once I applied the 22 inch-pounds to the center screw thread, as I'm profiling, I went ahead and I run the thumb screws down to lock the top of the clamp from toggling back and forth. And that gave me a much more consistent reading. I got about 2 CPM to 3 CPM higher on average, but you have to be careful when you're running the thumb screws down that you don't run them down too tight to loosen your initial torque value on your center screw thread. So just laid it out pretty much like that. I think that just shows a high-speed center drill to start the hole, for your number 7 drill bit. If you're going to use 1/4-20, drilling the holes, and then in my previous practice, anytime you're tapping and drilling anything, you always want to use the proper tool. This happens to be a tap holder, and the taps come in three different. When you get a tap set, there's 3 different ones. There's a starting tap, there's a middle tap, and there's a bottom tap if you're going to tap a blind hole. So, and all tap handles have a little 60-degree center in the bottom, and if you could use a center drill, which this is not the one I use, but you use a 60-degree center, you put it in your chuck and you lined it up like that, and if you have your unit secured, you can tap it and the hole will be tapped straight. Now, I don't know if I have a side view of that, Jerry. Let me go right there. Go forward. More. Right. Go back one. Go back one if you can. Right. Right. Go back one, or up one, or whatever. Right there. Now, the mechanism that the clamp is the thread screw is drilled into is actually on a bit of an angle. So the bottom of this unit's flat. You put it on a flat bed on your drill press and you're drilling. That hole will actually be drilled at a slight angle because that part of the head is actually bent backwards. So the hole that you're drilling won't be hitting on the upper clamp in the dead center, but that doesn't affect anything. All you're doing is using that to secure it. So, but Jerry asked me a question the other day. It seemed to slow his process down a little bit, and it did mine as well. But you get pretty quick at it. That's when I'm doing mine. I use my torque wrench to torque the shaft, and I use a 6-inch crescent wrench to loosen it as I'm moving the shaft back. So it's really a little bit quicker. So, and the other thing that I found that I don't have to twang or do excursions 3 or 4 times to get a number. Usually it's 1 or 2, and I can get my good average in. So that it shortened that process a little bit. So, yes, sir.
Are those thumb screws? Are they just when you actually get your torque set and are they just down finger tight?
Just finger tight. Just run them to where they touch. And the end of mine, if you go to one of the original pictures of this laid out on the table, I think I have that. Now, go back, I think it's keep going. Right there. No, I don't have it on that one. There's a picture of the thumb screws on the table. Right there. Now you'll see what I did in mine. On the very bottom, I've undercut the threads. Typically when you're doing machine work, on a piece of all thread, you undercut the back or taper it to where you can get a very good contact between your mating surfaces. So that's the reason mine are that way. And I actually made those thumb screws myself, and it's just a bottom tap 1/4 inch, 1/4 and a piece of aluminum, and the top's knurled. You can buy those thumb screws from Granger. You can use a cabinet knob or whatever you want to use, an epoxy, a piece of all thread in it. I think mine are about 2.5 inches long. You don't want to get them too long. If you get them too long, they get in the way of the torque wrench. So you want to be just short enough. But it made that clamping system much better. You want your hoop to collapse. You just don't want the hoop to collapse and lose energy between the top clamp toggling back and forth if you just have a center screw thread that's in contact with the movable clamp. In a really perfect world, if we had a clamping system that went around the entire hoop, then the hoop wouldn't be allowed to collapse because you'd have applied force on 360 degrees. But I'm thinking that we want the hoop to collapse a little bit because that's going to give the reading of excursion at that beam length. So it seems to work pretty well for me, and it's got me some consistent readings.